So this point is very, very important from the point of view of gate exam or theory exam, because this is the basic building block of your CMOS circuit. Okay, as I told you that in VLSI chip there are the gates available. So gates are designed using this CMOS circuitry, that is PMOS and NMOS connected in the proper fashion, and that you are implementing. So this particular CMOS is the basic building block of that IC design. Okay, so I'm moving further. So what is the outcome of this today's lecture? After completion of this lecture, student will be able to explore the CMOS inverter voltage transfer characteristic. This voltage transfer characteristic is named as a VTC curve. What? VTC. So although in exam it is mentioned like VTC, what is meant by VTC? Voltage transfer curve, that you have seen in practical of microwind last waveform, where you are switching voltage, you are getting VDD by 2. So that is called as a voltage transfer curve of inverter, and it is very, very important. So in today's lecture, we'll exploring detail of that particular curve. Now, in starting lecture, where we have taken basics of MOSFET, everything, I told you one important thing, that there are two types of MOSFET, that is enhancement type of MOSFET and depletion type of MOSFET, but we are moving towards the enhancement type of MOSFET, because enhancement type of MOSFET is like normal switch. Whenever you are giving pressing the button, the device will turn on, and whenever button is not pressed, device is off. Means it is normally day-to-day way of interpreting your switch. Same way enhancement MOSFET works, that whenever you are applying voltage, the device turns on, and whenever voltage is not applied, device is off state. So normally off switch enhancement MOSFET, and for the switching purpose, and in this digital circuitry, CMOS circuitry, everywhere we are using MOSFET for the switching purpose only. That also I cleared in the previous lectures. We are not using it as an amplifier or anything else, but just we are using it as a on-off purpose. So on-off purpose means, as you know, that MOSFET works on in a 3 region, that is cutoff region where the device is. So first is the cutoff, second is the linear, where the current increases with increasing voltage VDS, and third is the saturation region, where the current is maximum. Okay, and in that particular saturation region, your MOSFET is acting as. Can you put your comment in chat box? In saturation region, MOSFET is acting as a. Saturation region, in saturation region, MOSFET is acting as constant voltage source, constant current source. That way I am asking. So it is acting as a, yes, Yogesh, you have given right answer. Umesh also given right answer. So it is acting as a constant current source. Yes, many of the student giving. So why? Because where the current is constant, whatever increasing VDS. Okay, hope you are recalling the things. Yes, thank you for your reply. Now in saturation region, it is acting as a constant current source, where current will be constant, whatever increasing the VDS voltage. Okay, so here whenever we are having CMOS inverter, why we are preferring CMOS inverter over BJT as an inverter? Because BJT can be used as an inverter, but why we are preferring CMOS circuitry as an inverter? As you know, CMOS is having advantages that it occupies less space on small area. There might be thousands of transistors we can design. Secondly, power dissipation, that we have in last lecture we have considered. It is negligible in the static steady state mode. So we are preferring CMOS. Now, what is the advantage of CMOS inverter? So here, first thing you are able to see the full output voltage swing from 0 volt to VDD you are getting. What is mean by this? That if my input voltage is 5 volt and my ground is 0, so I will be getting full swing from 0 to 5 volt. I will not be getting 0.5 to 4.7 like this. There will not be voltage drop, but I will be getting whole voltage from 0 to VDD, that is 5 volt if I have given, that 0 to 5 maximum swing I am getting. Okay, so this is why, because you know that PMOS passes strong 1 and NMOS passes strong 0, and that's why we are getting maximum swing at the output. Okay, and it is having result in a high noise margin, means allowable noise, particular noise factor. So this will be you are seeing in the coming lectures. In the next lecture we have planned, that is on noise margin only. So this is main advantage, that you are getting maximum voltage swing. So if my voltage is 12 voltage, maximum voltage swing means 0 to 12 voltage I will be getting at the output side. Okay, so this point is clear. Hope I'm considering. Second, as you know, a well-designed CMOS inverter therefore has a low output impedance. What is meant by low output impedance and high input impedance? As you know, the MOSFET is having high input impedance because SiO2 layer is present at the input side, and that's why there will not be current flow through the gate. Gate is having zero current flow. There should be zero flow at the input side. Meaning of that, it is less sensitive to the meaning of that, it will not consume more current from the power supply. Okay, same way it is having low output impedance. Always circuit should have high input impedance so that it consumes less, and low output impedance so that less sensitive to the noise and disturbances. Okay, so both the things we are having in the CMOS circuit, a CMOS structure. The input resistance of CMOS inverters is extremely high. I told you, SiO2 layer is there, and that's why resistance of MOSFET, input resistance of MOSFET is very, very high, and steady state input current is nearly zero. So how you can relate that with this? That I told you, gate current will be zero, and that's why although the device is on, PMOS is on, it will not get path for current to flow from VDD to ground, as it doesn't carry the current. So gate current will be zero, and that's why there will not be direct path from VDD to ground for current to flow. So in steady state means when input is not changing from 0 to 1, the device will be off, one device will be off and one device will be on, and that's why there is no direct current path for current to flow from VDD to ground. So this already we have covered in the last PPT of power dissipation. Steady state power dissipation is negligible except some power dissipation due to leakage current. Same I have explained earlier. So because of only leakage current, which is because of minority charge carrier present in the circuitry or present in the that particular N or P doping. So because of that only current is flowing. Although circuit is in reverse bias, but because of minority charges, current will be flowing, and that is very negligible. So steady state power dissipation in CMOS is very less, and because of this reason, we are choosing CMOS inverter over BJT. Hope the things are clear with you. That is maximum swing from 0 to VDD. It is having high noise margin. Means it adapts the noise. It is immune to noise. We can say it is having high input impedance, low output impedance, and static power dissipation is less. Now moving towards our first poll question: which type of MOSFET is used for switching circuit? Switching means where that particular MOSFET is acting as a switch only for on and off. So which MOSFET is used? So I'm closing this poll within 5 seconds. 5, 4, 3, 2, 1, and 0. So 77% student voted, and I'm not that much happy by seeing the result. Hope you are able to see the result. So as I told you so many times, and from first lecture I'm repeating, still you are not concentrating, as this particular result shows that you are saying depletion MOSFET. What is meant by depletion MOSFET? Depletion MOSFET is already on. When you are not giving input also, this is already on. And what we required, whenever input is given, the device should turn on like a normal switch, which is used in the in your home. So it is related to enhancement type MOSFET. Enhances means whenever input is given, the current enhances, current increases, or current flows. So that is the enhancement type of MOSFET. So please clear your concept. This is enhancement type of MOSFET. Now moving towards this next PPT over here. So many times you have seen this particular thing. Again, I am repeating over here. First thing related to inverter is that whatever MOSFET you are using, that should be an enhancement type of MOSFET. So whenever you are writing anything related to inverter at start, you have to start with this thing, that whatever MOSFET, that is CMOS means PMOS and NMOS, both the combination of that you are using. So whatever MOSFET you are using, that should be enhancement type of MOSFET only. because enhancement type of MOSFET is acting as a normal switch which you are using in day-to-day life. Okay, so this is the first thing. Second thing is whatever PMOS you are using, because I told you CMOS is related to combination of PMOS and NMOS. Okay, so I need to connect PMOS somewhere and NMOS somewhere. So I have already taken why PMOS is connected in pull-up network because it passes strong 1, and NMOS is connected in pull-down network because it passes strong 0. So that way you have to always connect PMOS in pull-up network, that is above side, which is connected to VDD, and pull down you need to connect NMOS. Pull down means to the ground side. So it should be connected, source should be connected to ground for the NMOS, and source should be connected to VDD for the PMOS. And this notation should be perfect. Otherwise, if you are doing drain and source and something differently, it will interpret different circuit. Okay, so this thing is very important. Source with VDD and this source with ground. So I want source at the upper side, source at the lower side, and in between that there is a connection of drain, and inputs are connected together. As I told you, again I am repeating to clear your concept. This bubble doesn't indicate that whatever input you have given will get inverted. It is just showing that your input, this device is active low circuit. Active low means when 0 is applied, device will turn on. And what is meant by active high? Then you can put your things in chat box. What is meant by active high device? Active high circuit? Please fast do it. Do your comment. Give your comment in the chat box. So active high device means yes. Yes has given answer. Umesh also. When input is 1, the device will turn on. Okay. So hope you understood. Thank you. Oh, many of the students giving answer. So active high means when 1 is given, device will turn on. And what is active low means 0 is given, device will turn on. That way you need to think. Don't interpret it differently like the inverter. That 1 is given, so 0 will be done, and that way it will be working. Don't go in that mindset. And last and very important thing, that to avoid body effect, what I want, that suppose this is the P MOSFET and this is the N MOSFET. So suppose VT of this MOSFET is minus 0.7 because this turns on at the negative voltage, and VT of this is plus 0.7. So this should be matched, means it should be 0.7. It should not be 0.7 and 0.6, 0.5 and 0.6. Likewise, it should not be there. To have same VT, that is threshold voltage where the device is turning on, at same voltage both the device should turn on. That is this for minus 0.7 and this for plus 0.7. Exactly complementary operation I want. Complementary means once this is on, this will be off, and once this is on, this will be off. That is the complementary operation, and that's why VT should be exactly same but in opposite in sign. That is this minus 0.7 suppose, so this is should be 0.7. Otherwise, if you are not connecting body voltage, giving body properly, connecting body to the proper voltage, what will happen? There will be change in VT. That already we have studied in the previous lecture. So in chat box, just give the comment, or I will be giving poll question. For which MOSFET you need to connect body to which particular voltage? I am launching that poll. Don't get confused. Think before answering. Okay, 30 seconds I am giving. P for P, N for N. In this way, I told you to remember. So what is P for P, N for N? Just recall that thing. And most of the students have given right answer, that P for P means for PMOS, body should be connected to P, that is positive, and for NMOS, body should be connected to N means N MOSFET negative, N negative. So VDD and ground. Instead of ground, if you have written VSS, then also VSS is what? Is the ground only. As I told you, in this MOSFET, VDD is acting as a VCC, which is you are considering in BJT transistor, and ground is a VSS. Okay, so I am hiding this particular pole over here and moving towards repeating. So this circuit already you know, and many times you have gone through it. So here just view the notation properly, because on this only we are playing today. Okay, so this is VGSP. Why VGSP? This is gate and this is source of what? P MOSFET, and that's why here its suffix is written P. Related to this VDS, it is related to P MOSFET or VSD, or we can say. And over here, this is VDS related to N MOSFET, and this is VGSN, which related to what? Your N MOSFET. Now, you know that if I am giving input high voltage, what will happen? Just tell me in the chat box, because I want to interact with you, and in online session it is not possible, but I will try to interact with you in the chat box, through chat box. Okay, so can you tell me when I am giving logic 1, what will happen? Which device will turn on? Yes, do it fast. When 1 is given, which device turn on? Yes, many of the given right answer. Aishwarya, just think on that. So when 1 is given, this is active high device, means your NMOS will be on. And when 0 is given, yes, stop, no. Thank you for answering and having active. Over here, when 1 is given, what will happen? This device will be on and this will be off. This is the active low device. It will operate only on 0. Okay, so suppose I have given 1, so what will happen? This will be in off state because this is related to NMOS. It is in the pull down and this is in pull up. So PMOS will be on and NMOS will be here. When sorry for confusion. Here, when 1 is given, what will happen? The device will be on, this NMOS will be on, and this PMOS will be off. Okay, you're able to see this. Now, as the device is on is shown by this resistor. Why? Because when device is on at starting, what will happen? As my input voltage VDS increases, my current also increases. Means it is acting in a linear mode, and linear region, it will be defined by the resistor. Okay, so that's why it is mentioned by the resistor. Now when input is 0, what will happen? If I have given input as a 0, what will happen? This device will turn on, and as this device is on, I am not saying that it is in saturation. It is just on. It is not off, it is on, and that's why it will be acting as a resistor, because where current increases with increasing the voltage VDS, and this device will be off. Now when this device is on, capacitor charges towards VDD, and as we have connected PMOS over here, PMOS passes strong one, so capacitor will charge up to VDD. And when this device is on, what will happen? Capacitor will try to discharge to this particular device, and it will fully discharge to 0. Why? Because NMOS passes strong 0. This concept already I have taken in previous lectures. Many lectures I have repeated this just for your understanding, repeating now. So this is the thing. So hope the things are clear to you and clear in your mind. So moving further related to this point. Now this is very important, and this need to write in your book properly. Okay, because if you misunderstood anything or you are not listen properly, it will simply rule means it will be not of any use, means you will not be understanding anything. So here you are able to see this diagram. Everyone must just concentrate properly, because everything is over here is very important. Although you are seeing this one PPT, but it will nearly take half an hour to explain this particular PPT. Now here you are able to see this particular diagram, which I already told you. Proper notations are given. Now here these particular equations are very important. Depending upon this, we have find out this particular values. Okay, so what is meant by this particular equation? Hope you are able to see it properly. So this is drain current of P MOSFET. So drain current of P MOSFET is what? IDSP, and drain current of N MOSFET will be what? That is IDSN. Okay, and both are opposite to each other. Why? Because this turns on negative voltage and this turns on positive voltage. So as you know, the current will be equal and opposite. So I can write like this also: IDSP equal to minus of IDSN, or IDSN equal to minus of IDSP. Likewise I can write. So hope the things is clear over here, because voltage we are applying VT is 0.7 minus 0.7 over here, and here plus 0.7. Okay, now just see over here, I have shown some arrow. I need to first find out VGSN. Gate to source voltage for N MOSFET. Okay, so what is gate to source voltage? This is N MOSFET, which is connected in pull down network. Just concentrate properly, because this 15 minutes point is very important. If you get diverted, this will be difficult for you to understand. So this is VGSN, where this is what is your N MOSFET, and this is gate of N MOSFET, and this is the source of N MOSFET. That's why if I want to mention VGSN, which is related to gate and source. Okay, so it is mentioned VGSN. Now just tell me, what is VGSN voltage present over here? It is nothing but from this to this, and as this is connected to ground, so my VS is also ground. So VGSN is nothing but a V in. Can I say? Yes. Can I say VGSN equal to V in? Yes, Supriya, yes, you are right, input voltage. So I can say VGSN is nothing but a VE. So same way it is written over here. Everything you need to find out from this. It is not coming directly from anywhere, from any book. Just it is written from this only. Okay. Now I need to find VGSP. Just concentrate. VGSP is what? This is gate and this is source. Now this is the direct gate to source. We are finding like this, but this is somewhat reverse. If I want to say VGSP, so I need to go from down to up, and if I am to tell VGS, so it will be what? V in minus VDD, because over here I am going in this way. Okay, and if I want to say VSG, VSG in the normal way, what you need to do? That is over here VDD minus VN. What is VDD minus VN is equal to VSG. Okay, but I want VGS. So opposite of that, so VGS is equal to V in minus VDD. Hope the things are clear. Okay, because these are very important, because I am just going from VGS, and that's why it is V in minus VDD. If I am want to write VSG, it will be VDD minus VD. Okay, so now what is VDSN? VDSN is related to N MOSFET. So this is N MOSFET D and this is N MOSFET source. So VDS is nothing but what? Is V out, because here you are able to see it is nothing but a V out, and that's why it is mentioned as a V out. And over here, what is the meaning of this? VDS, D and S. So same way as you have mentioned over here, V out minus VDD. We are going from this to upward side, and that's why V out minus VDD. So hope that these are very important, and you need to write it in your book, because on this we are drawing this particular table. Okay, so here you are able to see this table. Now, what is the use of this table? Why we are drawing this table? Because as up till now you have just seen that when I have given 1, this device is on, and whenever I have given 0, this device is on. But what is happening in between? 1 is means logic 1, I am saying, means I have given 0.5 voltage over here, so this device is turning on. But what is happening when I am giving 2.5 voltage? I need to think on that, because MOSFET is operating in the 3 region, that is cutoff region, saturation region, and active region. So it is changing its region depending upon the input voltage you are applying. And up till now you are just knowing that if I have given logic 1, that is 5 voltage, this will be on, and whenever I am giving logic 0, this will be on. But in between that, what is happening, how they are switching, to understand that we are having this table. Okay, so every time it is changing its mode from saturation to cutoff to linear, like this. So how I have written this, for that this particular diagram is there. You need to concentrate properly and draw with me. Okay, now first we will going towards, hope the things are clear, because this is somewhat complicated. Ma'am, can you tell how IDSP equal to minus? Shraddha. Now, as you know, this is complementary circuit. As you know that when PMOS is on, NMOS is off, and PMOS turns on at minus 0.7. So that characteristic will be in the third quadrant. PMOS characteristic will be this VI characteristic, just as I told you. NMOS is like this. From this way, you are drawing the NMOS first quadrant, but PMOS will come in third quadrant. So because voltage is negative, and that's why current is negative. Okay, so that way it is the thing. Now here, hope the query is solved. Now I am moving toward this point, and this is very important. Here I have written V in. What is V in? I can give V in as a 0. I can give, suppose I am considering VDD as a 2.5. I can give in between any value to the V in. And in that way, how the transistor is working, in which mode it is working, I need to find out. So here, just for by a space of 0.5, difference of 0.5, I have just increased. So V in is suppose 0.1, 0.5, 1 volt, 1.25, 1.5. Likewise, difference of 0.5 voltage I have mentioned. Any query related to this? Somebody raised a hand. It is okay. So this is clear. Now I need to find out VGSP and VGSN, and that's why I have written VGSN is what and VGSP is what, and that we have find out over here that VGSN is nothing but a VIN. So whatever VIN is there, it is nothing but a VGSN, because as you already know and I already told, so same I am writing over here. If VIN is 0, my VGSN will be 0. VIN is 0.5, this is 0.5, and same way I am getting. But now whenever I need to find out VGSP, what is VGSP? Which is nothing but a VIN minus VDD. So VIN is what? 0, and VDD is what? 2.5. So 0 minus 2.5, what you are getting? That is minus 2.5. And in this way, we have find out this values. So exactly reverse order you are getting, and minus sign is what? Because this is active low device, that is the means active low signal is given, that is 0, or in terms of negative, then and only then this device will be on. Okay, at 0.5 minus 0.5, will it be on? No, because I told you the threshold voltage is 0.7 minus 0.7. So at that point that will be off, that PMOS will be off. Likewise, you need to remember the things. Okay, so hope up to this point that things are clear in your mind. Can I move forward? Move further in the further PPTs, coming PPTs. Anybody having any problem? Because if you are having problem, it will not be solved our issue. Okay, yes, Rituja is saying yes, understood. So again, I am repeating, first you need to draw. If the working of inverter is given in the exam, ask in the exam for the theory, subjective type of thing, if that is not possible in this situation. So first you need to draw this diagram with proper notation. You need to mention this particular equations, and then you need to draw this table. And I need to find out what is the VGSN and VGSP. That's why I am finding for each input, I am finding this value. Hope the things are clear with you. Now, after that, it's a very important, and you need to parallelly do with me. I have done something in the paint for understanding this particular graph, how to draw this graph. This is very important from the point of view of understanding. So I'm leaving this particular part and going to this paint. Okay. So I have done something over here for you to understand the thing properly. So here you are able to see the graph, which is I have copy pasted directly. Now I am moving further how to draw, and same way you need to draw in your notebook, because this question will be in assignment one question, like explain the CMOS inverter in detail. So everything you need to draw properly. So first thing is what I have drawn. First I have drawn this particular VI, means that is the ID versus VDS. Here it is ID versus V out, output voltage. Okay, hope you are doing with me. I have tried my best to actually show you how the diagram will be drawn. So this is the first thing. Now this is the graph we are drawing related to N MOSFET, because already we have seen that we are drawing like this, and we are drawing like this. That is saturation, cutoff, and linear. So first thing you have drawn this. Second, you need to just add this line. Now here, just see my arrow. From this to this, we are drawing our P MOSFET characteristic, because I need to see when PMOS is on, what is the position of N MOSFET, or NMOS is on, what is the condition of P MOSFET. So for that, I am combining these particular graphs together. Okay, so this way you need to draw. Hope you have drawn properly. Next thing, you need to find out the middle of this particular graph. So I have drawn this line. This should be dotted line. This should not be that much dark. This is just for understanding that at switching, means if this is VDD and this is 0, means this is VDD by 2. So switching should occur at exactly VDD by 2. That is the main intention. So this is my VDD by 2 point. Hope the things are clear and you are going with me. Now, what I need to do? Now this color you are able to see somewhat light, but I can't do anything for that. So by orange, I am trying to tell you related to N MOSFET characteristic, where my input voltage is what? 0.5. Previously over here, input voltage is Vin equal to 0. Means Vin means where we can say VGSN, which is same as a Vin. So at this point, at on this particular line, we can say Vin equal to 0, means device is off, cut off. After that, if I have increased it up to 0.5, means VGSN is 0.5, means some current is flowing. And that's why you're able to see this particular graph. In this, we can see that here it is the linear region, and this is the saturation region where current remains constant. Next, you need to draw for another value of V in or VGS. So here for 1 voltage, it has been drawn. Okay. Again, you need to draw for 2 volt. So this is drawn for 2 volt, 1.5 volt, 2 volt, and then 2.5 volt. Likewise, we have drawn for all the values of V in, or we can say VGSN, because V in is VGSN is nothing but a V in for the N MOSFET. So hope the graph is clear. So this orange part, whatever you are able to see, this is related to N MOSFET. Okay, that's why I have mentioned over here. This is the saturation region for the N MOSFET, and this is the N MOSFET, where VGSN is equal to 2.5. Here VGSN equal to 2. As I told you, there are two types of graph in MOSFET. One is the VI characteristic, where the it is a graph between ID versus VDS at constant VGS. So this is the same graph, ID versus VDS at constant VGS. VGS is nothing but a V in over here. So we have taken a difference of 0.5 and I have drawn this graph. So this orange is related to what? Just tell me in the chat box which MOSFET, P MOSFET or N MOSFET. Just give your comment first. Yes, Prajakta, Rituja, Charan. Yes, you are understanding. So this is related to N MOSFET. Okay. Now I need to draw P MOSFET characteristic. Okay. So how to do it? Just go from this side. First we have drawn from this to this side. Now we are going from blue to orange side. So first we have drawn for 0, then 0.5, then you are able to see the blue color is changing. This is 0.5 and this is 0. Okay, this is over here. Now, have you done up to this? Hope you are properly. Now, why this is 0 is written, that I will be telling you. Okay, so understood. First you need to draw this particular orange line, then this blue line. Orange line is related to N MOSFET, blue line is related to P MOSFET, and we need to show overlapping of that so as to correlate our inverter circuit over here. Okay, now here we have written V in as a 0, 0.5, 1, 2 and 2.5. Why? Because I told you that VGSN is equal to V in, but here what is the condition? It is coming as a minus 2.5, but here you have written V in equal to 0. So I'm switching to the PPT to elaborate the thing properly. Over here you are able to see, here it is mentioned as a V in. What? V in is mentioned, not a VGSP is mentioned. So if VGSP is mentioned, you need to write down minus 2.5. But why we are not writing this minus 2.5 over here? Because I need to interact with you related to input voltage only. If input voltage is this much, what will be the condition for NMOS and PMOS? And if you are writing VGSP terms over here, it will be somewhat complicated or confusing. So whatever values you have written over here, it is written in terms of V in only. Okay, so that's why here we have written V in as a 0, 0.5, 1, 2.5, 1.5, 2 and 2.5. And here what we have written, when V in is 0, when V in is 0, what is my input is minus 2.5. So this is minus 2.5, because you just think, if input is in more negative point, means it is in saturation, means current is very high, that way this will be over here. Okay, so my current is very high because my voltage, whatever the input voltage given to this particular transistor, is more negative. Okay, if it is over here 0, means that device will be off, means current will be less, that way it is going down. Hope the things are clear, because this is very important. Otherwise you will not understand the concept, how that will be going from this region to another region. Hope the things are clear. Any doubt with you why we are written that V in? On the chat box, please comment. We are running out of time. It's 15 minutes remaining. Hello everyone. Is it clear with you why V in 0 is written over here? Yes, Rajat is saying yes. Yes, clear. Okay. So, okay, thank you for your reply. So this is very important. That's why I'm stressing over here on this point. Otherwise, it will be difficult for you to understand. Now I need to see how in this region, my NMOS is in cutoff and PMOS is in linear. This is very important, how I have written. So now, before going to this, how I have written this, but just I want to tell you the model of this. So I am just going to the next PPT over here. Okay, so I have written over here, and for your this one, just I'm copying this particular part and putting it over here. I'm not able to adjust it over here properly, but still we will try कि क्या हो सकता है. Okay, so over here you're able to see, just see this part particular. This is V in, this is VGSM, and this is VGSP. Okay, in this region NMOS will be in the cutoff and PMOS will be in the linear. Okay, so now this is related to first model. Means I have modeled this particular thing, model this for this region 1. So region 1 is what? Where my NMOS is in cutoff. Cutoff means device is off. So I have shown it as an open switch. And this PMOS is in linear. Linear means it is acting as a resistor where current increases with increasing voltage. So you can model this particular first region like this. Hope you understood the particular concept what I want to tell you, because this circuit whatever we have drawn CMOS inverter using PMOS and NMOS, how that will be modeled in different regions. There are 5 regions in which your device is working. Over here I have written region 1, region 2, region 3, region 4, region 5. So MOSFET is working in a, inverter is working in a 5 region. So how you can model that particular circuitry in different region. So where the linear particular device is in linear, represented by resistor, and where it is mentioned as a cutoff, mention it as an open switch. Okay, in second region you are not able to see, but I have mentioned over here PMOS is acting as a linear. So linear means what? Just tell me in the chat box what is meant by linear, how to represent linear one. Linear means represented by what symbol? Just give answer fast. Linear is represented by what? Just I'm putting it over here. Everyone, nobody wants to answer. Linear is related to resistor. Okay, yes, Akshada, resistor. And cutoff is related to what? Just write down in chat box what is cutoff. Cutoff is related to, I'm just showing over here. Cutoff means it is shown by open switch. Yes, yes, you understood. Open switch. Okay, now what is mean by this? Can you identify? Can you relate your recall the thing? Saturation, I have written saturation and symbol is mentioned. Why I have written saturation and symbol is this? Can you tell me? Yash Vardhan, you are switching only from offline online. Why you are playing like that? Is there any network issue? Yash Vardhan Singh, it is distracting me. So just tell me what is mean by this particular symbol. Why it is mentioned? Ashwini, it's open switch. No, I think it is related to previous answer. What is this? Just give it fast. I have started with that only. No, nobody wants. Just see. In saturation region, I told you your device is acting as a constant current source, and that's why this is the symbol of constant current source. When my NMOS will be in saturation state, it will be denoted by constant current source. When PMOS is in saturation, pull-up network mein rehta hai PMOS, so it will be shown by constant current source. So saturation region is represented by constant current source. Linear region is represented by resistor, and cutoff is represented by open switch. The things are clear with you? Hope the things are clear with you. Just I'm asking you again, just put the things properly in the chat box. Cutoff means what? How to denote cutoff? Do it fast. I will be giving only 10 seconds. Cutoff means it is denoted by, yes, 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 good. Open switch. Okay, stop. Now linear is represented about what? By what? Linear, linear. Linear region is represented by, yes, good, resistor. Okay, good, good, you are understanding. And saturation region, just tell me fast, fast. Saturation, saturation. Yes, 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 constant current source. Yes, so you understood each and everything, so I'm happy. Now over here I have shown all this region over here, and these models are drawn. So I'm just switching this particular mode over here so that that overlapping I can remove. Okay, so I'm deleting this particular part. It is coming over here. So hope the things are clear. So this is the module for each region of operation. So here I can say NMOS is in, sorry, PMOS is in linear and NMOS is in cutoff. Here PMOS is in linear, NMOS is in saturation. Here PMOS is in saturation, NMOS is in saturation. Once both are saturation, both are in saturation means both are fully on. As I told you previously, only one device will be on, another device will be off. But in saturation region, for the fraction of second, both the devices will be on. That we have seen in the second graph of the microwind. For the fraction of second, both are on and it draws the current. So that is over here. Means switching occurs at this region, region 3. Okay, कहाँ पे switching होता है? Region 3 में. And over here PMOS is in saturation, NMOS is in linear, and here PMOS is in cutoff, NMOS is in linear. Exactly opposite you are able to see. Here it was in linear, now this is in linear. Here this NMOS is was in cutoff, here PMOS is in cutoff. So opposite you are able to see, and here both are on. So is it clear in your mind how to model that particular circuit in different region? Hope the things are clear to you. So moving towards the next point, and I don't want to because this is linked topic related to whatever we have learned now. So now you are able to see over here. This graph is linked to this. This graph you got in the this one VTC curve where switching voltage VM is mentioned over here, which is VDD by 2. It should be 1.25 that I told you previously. Now here this graph is divided into 5 regions. In inverter, this VTC curve, voltage transfer curve, is this one that I was talking about. VTC means voltage transfer curve, and this is the voltage transfer curve where switching occurs over here and where both the devices are in saturation. Over here, this is the region one, as I told you how to model that circuit. I already told you, so I'm not going again. And this is the second region. This is the third region. This is the fourth, and this is the fifth. Likewise, this VTC curve is divided into total 5 regions. Now, how to see this particular transistor in cutoff or linear? For that, before going to that, I just want to launch another poll and give the answer very fastly because we are running out of time. So I'm launching. Give answer. Think over it before answering. Don't give wrong answer. Give it fast. Do it fast. Think before answering. I am not asking about MOSFET working region. I am asking about inverter working region. CMOS inverter works in how many region? I have shown model also for each region. How you are giving wrong answer? Give it fast. Last 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So I'm stopping. 73% student voted, and see what you have voted. Is it answer is 3? No. Answer is 5 because I told you this works in 5 region. I can show it over here. The screen is open. Over here, I shown you that it works in a 5 region. Okay, so just update yourself. So moving towards this point, I am running out of time. So I'm going fast switching this particular screen. So here I have just created this particular thing. So see this particular, somewhat I have dark shade I have used. Previously it was not visible. Just see when input is 0. What? I'm just telling when input to the circuit inverter is 0. So I need to see the waveform of when PMOS Vin is 0 and NMOS Pin is 0. So where is the NMOS PMOS Vin is 0? Are you able to see? This is the PMOS, as I told you in previous graph. Just link it properly. This is very important. Okay. So this is what is the graph of where the PMOS is having Vin as a 0. Okay, you are able to see. Hope the things are clear. Now you need to just highlight when NMOS is having input 0. So where it is? That is here NMOS is having graph or current when input is 0. Now see, when these two waveforms intersecting with each other at first time, where it is intersecting, just see, this is coming from this to this, and this is coming from this to this. So where it is intersecting, are you able to see this thing? I'm not able to take every time spotlight because it is losing the control of paint. So here you are able to see that PMOS is having V in 0, and here NMOS is having input V in 0. So current is like this, and they are intersecting at this point. First time they are intersecting over here. Same way, just this is very important. Again and again, I'm telling. Next, just see which is the next input, that is 0.5. So this is the 0.5 for NMOS, and this is the 0.5 for PMOS. Now, can you say over here? I can say for this first graph where over here intersection, I can say this is cutoff. Which cutoff? NMOS is in cutoff, and over here this is saturation, this is linear, and this is what is linear. So I can say PMOS is in linear and NMOS is in cutoff. Is it clear? It is intersecting first time. This is somewhat complicated, but just try to understand. I just want to find out the first intersection point of these two, PMOS and NMOS, for V in equal to 0. So at this point, I can say this NMOS is in cutoff because the device is in off state, and this PMOS is in saturation over here. Over here it is in linear. So I can say PMOS is in linear. Hope the things are clear. Just see another also. So I have drawn this thing, and where it is intersecting first at this point. Okay. So at this point it is intersecting first. So NMOS, this is in saturation region. For NMOS, this particular part is the saturation region, and this for PMOS, this is in the linear region. So I can say when my input V in is 0.5, at that time NMOS is in what? Saturation region, and PMOS is in what? Linear region. Are you understanding? That I want to tell you about this. Why this NMOS is in cutoff and PMOS is linear? When input is what? 0. NMOS is in linear. I have mistakenly combined these two. Actually, this should two be combined. Okay, I will update this on next PPT. So hope the things are clear. I will be taking this in another lecture also. But is it clear in your mind what intersection we are trying to take? Everyone, just put it your comment in chat box. We are finding intersection point of PMOS and NMOS, where it is intersecting first time, and at that point in what region PMOS is and what region NMOS is. Yes, everyone is getting. I am getting comment in the chat box. So again, see another. Now just you need to tell me in which region PMOS is. Greenish, green shown by green, PMOS and NMOS. So what is that? In which region PMOS is and NMOS? So intersection point is this one. So this is what is related to PMOS, and this is what is related to NMOS. So NMOS is in, just write down in chat box, NMOS is in, NMOS is in, do it fast, only 2 seconds remaining, 2 minutes remaining. NMOS is in saturation, right? And PMOS is in, PMOS is in, PMOS, right? Related to PMOS. Over here, PMOS is in linear. We have taken which voltage? We have taken 1.1 volt. Sorry, 1 volt. So where the PMOS is in saturation, straight line दिख रही है आपको, NMOS is in saturation, and PMOS you are getting some tilted line, means it is in linear. Okay. So I don't see that it will be completed in this lecture. So we need to take our second lecture for the continuation. But try to draw this diagram and just find out intersection. That particular table, whatever I have drawn over here, I have mistakenly mentioned over here that two I have combined. That is by mistake it has been done. I will updating this. So this two will be combined for this region 2. Okay. So NMOS is in saturation and PMOS is in linear. So I will not be able to complete this thing over here. Sorry for that. I thought it will get completed, but not possible. But try to draw that figure waveform. Otherwise, it will difficult for you to understand. You are getting that particular point time,